Hello, geometry class. Just to remind you where we were at, we were talking about trig ratios or trigonometric ratios. We did quite a bit of it on Friday, and now we need to pick up and we need to do more on this topic. So what I would like you to do is I would like you to have your calculator handy. Remember at the beginning of the year we said that you needed to buy a calculator. Now in geometry, some of you have been faking it with other calculators, and quite honestly, a lot of the geometry stuff can be done very easily with other calculators, but over the summer, especially since we don't know what's happening as far as when school will be able to open as normal, and especially because we don't really want to be sharing calculators, you need to get yourself a good calculator. Okay, I'm going to be showing you some things today, but as you can see on here, there's some leftover stuff from Algebra 2 that you can't do by hand. Okay, you need to have a graphing calculator that will graph. Okay, it's kind of a happy accident that this was left on here. This is not really part of your geometry lesson, but you need to have a good graphing calculator. This is the one I teach from, the TI-83 Plus, but if you get the TI-84 or the TI-84 that's rechargeable that has the pretty colors on it, that is fantastic. Not a Texas Instrument salesman, however, this is what I teach off of. So you really need to have one. You can take them with you to SATs, which is also very good. You can't use your phone on SATs. All right, so you want to have your own personal calculator for health and safety, and also because you need it. It is a school supply. It will be on your school supply list for next year. We can get by with whatever you've got for the end of this year, but for Algebra 2 and beyond, you need to have a good calculator. Okay, so our key word that we're going to put in right here, right now, is calculator. Okay, because that's super important and I want you to be able to go get one. All right, now that being said, all the work today is not all the work, but a lot of the work will be calculator work, and we'll get by with what you've got, but important. What we were talking about before was sine and cosine and tangent and how they relate to opposite over adjacent for tangent, opposite over hypotenuse, SOHCAHTOA for sine. Cosine was adjacent over hypotenuse and tangent was opposite over adjacent. We want to keep that in mind. That will come back. But we also want to keep in mind that, remember, we started off talking about it as they are ratios and they are equal ratios. So what happens is that every triangle that has the same number of degrees in one of its acute angles is going to have the same ratios. Those values have been found. They have been recorded. They were recorded as long ago as in ancient Babylon. There have been stone tablets that have been dug up with trig tables on them. So when we make the connection to that, Shadrach, Meshach, Abednego, and Daniel, when they were captured and they were taken into ancient Babylon and they were educated, we know that they were really smart and they were really handsome and they were educated, and one of the things that they could have been educated in, because the trig tables were found, was this very thing that you're learning right now, but they had to look it up on tables. They had to look up these numbers. Our numbers are stored in the calculator, and I need to be able to show you how to find those numbers. Okay, so our second keyword that I want you to write down right here, because it's a very, very interesting story, is Daniel. Because Daniel and his friends may have been learning this right along with you because they were captured and educated with all the best education that Babylon had to offer. Okay, so on your calculator, if you're asked to find the value of sine or cosine or tangent from a given number of degrees, you have to know where it lives in your calculator. So what you need to do first of all is you need to make sure that your calculator is set to the right mode. When you buy a calculator right out of the box or you use these simulators, a lot of times when they get turned off, it defaults to everything on the left-hand side being highlighted. Notice that this says 32 degrees. If we don't go down and make sure that our calculator is set to degrees, it's going to work in something called radians, which we don't get to in this course. Okay, that's advanced trigonometry, and that would come if you're taking the calculus road. That's when you would end up doing that, and not all of you will be taking the calculus road, but everybody can know about degrees. So you want to make sure your calculator is set in degrees. If the calculator is not set in degrees, it's going to give you all wrong answers. And this is something that everyone can do very easily. You click the mode button, you use your arrows to get to degrees, and you hit enter. Now, how do you get out of this screen? And to get out of this screen, we need to quit this screen. That's found in the second of mode where it says quit. And then we're back to a blank screen, and that's where we need to be in order to do these problems. Okay, so if I want to find the sine of 32, I need to take my calculator. Notice there are buttons here that say sine and cosine and tangent. You need to click sine 32. The end parenthesis is kind of optional, but I like to put it there just so that I'm used to seeing it. The 84s show things a little bit more elegantly, but we want to take the sine of 32, and this gives you 0.5299. I've got here as a screenshot, 0.5299. You want to find your answers to 4 decimal places. Okay, the exact answer isn't even here. It goes on and on and on forever, but 0.5299, go to 4 decimal places past the decimal, use your rules of rounding, check to the right of it to see if you round up or you leave it there. Remember, 5 and up rounds up, and then below 5, you leave it alone. If you want the cosine, you need to use the cosine button. Okay, this should be pretty simple. Cosine, 23. And it tells you that every one of those similar triangles that has 23 in one corner will have the same ratio of adjacent over hypotenuse, 0.9205. 0.9205. And then anticipate a little bit, try tangent. When you push the tangent button, 6.3137, we hit here. We want to round up because this is 5 or above. So make sure you use your rules of rounding. So this is right now a button pushing exercise. If you have only your calculator from your computer, make sure it's in scientific mode. Okay, notice here it has trigonometry. There's your sine, cosine, tangent hiding right there. If I want to make sure up here it says degrees, okay, there would be radians, there would be G radians. We want degrees, make sure it says degrees on there somewhere. This works a little bit differently. I want 32 and I want to take the sine of it. And for that one, you have to hit the sine button afterwards. Not quite as natural. You have to learn whatever calculator you have, test it out, and make sure that you know where to find the correct values for these. Okay, so if you have one of the basic ones on your phone, you're probably going to have to resort to putting the number in first and then hitting the sine or the cosine or the tangent buttons. It's under trigonometry, or you should be able to look up and find it. Do that. Stop the world right now and make sure you find whatever calculator you can and you can get these numbers. Okay? Now that is if you're given the number of degrees and you need to find the sine or the cosine or the tangent. If you are not given the degrees, but you are given the values and it says find the approximate value to 4 decimal places, this is the same thing that we did before. Okay, sine, cosine, tangent. Sine of A, okay, we need, this is our opposite. Okay, over here's our opposite, and here's our adjacent, and here's our hypotenuse. Opposite, adjacent, hypotenuse. So when you begin to do this problem, and you're trying to find the opposite over the hypotenuse, you write it down like that. In this case, you don't need to rationalize the denominator because you're just trying to find an approximate value. But you do have to be careful with parentheses. We are not pushing the sign button for this, okay? Because we don't have the number of degrees here. Notice here when we had the sign button, we had to have the number of degrees, the thing that went here. You're just dividing out the fraction. We're just taking 14 divided by, watch the parentheses, 2 times the square root, not the square root, second of the square of 74. Be careful with the parentheses. This says 2 times the square root of 74 together as a group is in the denominator. And that's the way you do it to get the number 0.8137. So 0.8137 is your answer to that problem. If you want, you can simplify it first so you don't have quite so much to do using that tool. So you're doing 7 divided by the square root of 74. It makes it a little bit simple, not so many parentheses to have to deal with. 0.8137. Okay, so use your tools that you have. This is all you're getting is the decimal approximate value. When you keep the square root and you have to do multiplying by square root 74 over square root 74 to rationalizing the denominator, that's the exact value. This is the approximate value. Okay, so to find the approximate value, you need to divide. So what I want you to do, write down another keyword. Your third keyword is going to be divide. Okay? All right. So moving right along. Oops, still not done this one. Cosine, adjacent over hypotenuse. Here's our A. Our adjacent is 10. Our hypotenuse is 2 square root of 74. So when you do 10 divided by 2 square root 74 and you simplify it, you have 5 over square root of 74. Use your calculator. 5 divided by the square root of 74. Very nicely like that. And we get 0.5812. Tangent, TOA, opposite over adjacent. Opposite over adjacent. And that one you can almost do in your head, 1.4. Okay, so if you're finding the approximate value, you do not have to rationalize the denominator. You just put in the numbers for sine, cosine, tangent, SOHCAHTOA, and you simplify and you get a decimal. This one actually comes out to be the exact value. 14 over 10 is 1.4 exactly. But when it says approximate, if it doesn't come out even, you just go to 4 decimal places and leave it at that. And finally, we have this one. This one's kind of fun and tricky. It says if cosine A is 3/5, find the other two. So in other words, find the sine and find the tangent. But I'm only given the cosine. Yes, you are. However, we have something special happening with this. The special thing that you have happening with it is that you know that you have a right triangle, and you know you have a cosine, and you know SOHCAHTOA, you know that cosine is adjacent over hypotenuse. So we know that in our triangle, if we have A, B, and C, make C always be your right angle, and whatever it's the cosine of, there we have adjacent over hypotenuse. So you need to fill in the 3 and the 5 where they belong. Okay, the hypotenuse, easy to find, that gets a 5. Your adjacent is here, that gets the 3. That leaves the opposite to find. We need to find the opposite to do the sine and the tangent. So what you need to do is a squared plus b squared equals c squared. A squared plus b squared equals c squared. This one's a, this is b, that's c. A squared plus b squared equals c squared. We need to simplify, we need to solve. And this gives us 4 as our remaining side. Okay. And so now my sine is opposite over hypotenuse. It's 4/5. And the tangent is opposite over adjacent, which is 4/3. And that one is now finished. What you will notice in some of the homework questions is that it also asks you to remember things about your special right triangles and to recognize some patterns. Remember we had 45, 45, 90 and 30, 60, 90. I want you to give those a try and see what you can figure out with them. I'm going to just bring this up really quickly and remind you that when you have a 45, 45, 90 triangle, okay, and you have a 1 in one side, and you have a square root of 2 over here, you should remember that in a 45, 45, 90 triangle that your pattern is these two match and this one is the square root of 2 times that. So this will tell you you have a 45, 45, 90 triangle and that this side is 1. So if you wanted to find this value, even if you didn't know it was 45, 45, 90, you could do sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, if you can recognize the pattern. They could give it to you in another form, okay, where you don't know what it is, but if you happen to notice that it's following that general pattern, like if this is a 7 and this is a square 7 square root of 2, that would tell you, wait a minute, this is following my square root 2 pattern. This is a 7, and you could find your sine, cosine, and tangent values once you have all those. I don't remember if they have 30, 60, 90, but it's always good to review these concepts, because if you'll remember, our good 30, 60, 90 pattern was that this side would be 1, this side would be 2, and this side would be the square root of 3. We can check that. 1 squared plus square root of 3 squared, does that equal 2 squared? Well, this is 1 plus 3, that equals 4. Okay, yeah, that works out. Here's our nice pattern. Okay, so anything that follows this pattern, once again, once you recognize that you have that pattern coming out, you can use that. So for example, if I wanted to find, if this is A, and I wanted to find the sine of A, here's my opposite, here's my adjacent, and here's my hypotenuse. My sine of A would be 1 over 2. Okay, now there are just a couple of questions that sneak in there that refer back to your special right triangles. It's always good to remember as much as you can, not necessarily just for if it's on the test, but it's always good to remember what you can, because these type of triangles love to show up on the SATs, which helps you place very well for college. So I just wanted to take a quick minute and add that in as a little extra something to help you to make sure that you get as much out of this geometry class as you possibly can. All right, that is enough for today. And please make sure that you are doing your best. All right, God bless you and have a great day.